Okay, so this is the solution video for the first practice problem, and in this series of solution videos of practice problems, I'm not going to be going over the questions because you're only watching the practice problem solution because you have already tried the practice problems yourself. So I'm very sure that you're familiar with the questions. I'm not just going to go over it again. All right. So this problem was actually, this is a simple trigonometric problem, basic geometry problem, but I put this problem in so that you can start to brainstorm about the things that are around you. So the question asks you to calculate the length of a flagpole, right? And here in the hint, I'm saying that brainstorm how you can measure the length of the chord if it were a real scenario. And I have not given you the informations that you require to calculate the hands of the triangle, the angles of the triangle, right? But if it were a real scenario, the purpose of the question is that it should invoke your thinking and how you look at your surroundings. Maybe after reading this question, you can find something similar that's around you. Maybe you cannot find a flagpole, but maybe you can find an electric pole that is tied to the ground the same way this flagpole in the example is. So how can you measure the base of the triangle with the tools that you have? That was the thought invoking thing, the purpose of this question. Okay, and then in the simplified version of the question, I'm giving you a hint as to how to calculate the base of the triangle. So if you can somehow solve this practice problem 1, then for similar scenarios you can use your skills and the tools at your disposal. Maybe you don't have a measuring tape, maybe you just have your shoes, you know what size your shoes are, or you know how long your feet are, right? Or maybe you are solving it in another way. So the way I did it was by counting steps, but you maybe have another better way to solve it more accurately. But the purpose of this question was that after solving this or understanding this, you can calculate, measure things similar to this, maybe a flagpole, maybe an electric pole, or whatnot, or maybe even the height of a building from the ground level up, right? Okay, so maybe you can do those things. There are advanced ways to calculate the height of a building, but the basic principle is using the triangle to calculate the height of a building. So I just wanted you to have the basics. So even if you don't have any fancy equipment, you can do approximate calculations yourself after going through this book. Okay, now let's take a look at this problem and the solution to this problem. So at first here, I'm giving you that a boy named Jimmy, he walks in a particular way, and per feet is 5 inches. His feet are 5 inches, and this is how he walks. So if it takes him 20 steps to reach from there to there, that means this distance is going to be 5 times 20, which comes out to be, let me draw a triangle here. So this is our reference triangle. So we are getting at 100 inches. And then I'm also giving you that the chord is twice the distance of the base. Now, if you were to practice this in an actual scenario, no one is going to tell you that the chord is twice the base or something like that. So here you need to apply more intuition and brainstorm how you can get the second value, the second measurement, so you can carry out the third one. Okay, so here I'm saying it's twice, that means this is going to be 200 inches. Okay, now we need to find out the height of the flagpole, so let's just call this A. And if we apply the Pythagorean theorem, we can easily calculate this. So 200 squared is equals to square root of A squared plus 100 squared, and then from here you can get the value of A, which comes out to be 173.21 inches. And now for the angle, if you want to get the angle, so we're talking about this angle, right? So if we make this the angle, then this side here becomes the perpendicular. So we know the measurement of the perpendicular. So if we just apply the sine theta, it comes out to be 100 inches divided by 200 inches. That means theta, the angle, that angle, particular angle, is going to be sine inverse 100 by 200, which comes out to be, I haven't done the calculation yet. Let me just bring out my calculator and do it quickly. You can do it yourself, but still, let me do it. There you go. Comes out to be 30 degrees. Okay. So it is coming out to be 30 degrees. So let's say you have a real world scenario like that, and you can only measure the base, and you cannot calculate anything else. So I want you to brainstorm about that, how you can solve this issue, how you can calculate that. But this is something that we tackle in another practice problem. Okay, and in that practice problem solution, I'll show you how I did it, but that's not the only way, and I do believe that some of you can even come up with better ways to do it and more accurate ways to do it. Okay, so yeah, that was it for this video. Thank you very much for watching, and I hope you're enjoying the book.